Good evening, everyone. I hope I am audible, right?
Yeah, good evening.
Yeah. Okay. So actually, from today onwards, I'll start the DL part, deep learning. Okay. As per discussion with Samir, I'll start DL from today, and I hope you people are already practiced ML part. Uh, Maybe you got some idea, right? How
Yes, sir.
models are going to be created and how to deploy ML into some environment, right? Maybe through stream data array, maybe other even Flask. Of course, I didn't focus on Flask, but most of the time, it's Streamlit is very simple platform to deploy your ML models. Okay. So now, first, let me explain in today's session why DL is important. What is the difference between ML and DL? Maybe in some of the places you may read ML is a subset of AI. Again, DL is subset of ML, something like that, right? Right?
Yes.
Yeah. So, but I'll focus uh, in a different way why deep learning is important and what is a simple way I'll try to explain the importance of deep learning and again why deep learning is very important nowadays. So deep learning is actually it's only the new term, but it's came into uh, the combination of ML and it is basically if somebody asks you, can you define machine learning and deep learning dependency, or can you define deep learning in terms of machine learning? Then simple answer is deep learning is nothing but uh, Machine learning with the neural networks. Machine learning with the neural networks. So if you remember so far, whatever the concepts we see in machine learning, we never used the word neural network, right? We didn't use neural networks. But now, when we are going to start this DL part, we are supposed to use neural network. Okay. And again, of course, neural network is not a new thing. Okay. So it's already it's there almost from 60s, 1960s onwards. So it is already uh, evolved with the AI only. But only the thing is when it is coming into the implementation, when it is coming into the existence, because of various reasons, because of various challenges and limitations, we are not going to use this. Okay, so it's all about how the neural networks, especially neural networks means artificial neural networks. Okay, so also known as ANN, machine learning with artificial neural networks. It is going to deep learning is basically simple definition of the deep learning is training artificial neural networks to learn from the data. How we are going to train these artificial neural networks? To train from the data. Okay, so that it's going to be trained. So what this neural network, again, neural network is it's come from biological neural network. So this is from human beings neurons only again. So actually this ML is even DL. DL is a purely block box. So what is block box? Anyone knows what you mean by block box? Maybe you may studied block box in software engineering. We are
Testing.
doing, yeah, testing, right? Maybe
Right.
unit testing, component testing, and block box testing.
Right.
Different. But what is block box? Any idea? So block box is nothing but will give input, and will get output. We don't know, but we don't know exactly what is happening in between. So even here also same thing. And deep learning also, because some of the deep learning models may need even days of time for training. Okay, and they need lots of computational resources. They need a high-end computational resources. But still, we don't know what is happening during training process. No one knows what is happening exactly. Even if you see biological neural networks also, for example, if I talk about something like you're taking an injection from a doctor. So at that time, maybe you are crying or you are seeing some comedy movie. Okay, at that time you are laughing. But exactly you know what is happening uh, in your nervous system. Which neurons are getting activated when you are laughing? Which neurons are getting activated when you are crying? Exactly, anyone knows?
No.
No, right? No one knows. So even our biological neural network also, it's all about predictions only. We may it's all about predictions only. But it's also, we can say, it's a full of black box. We don't know exactly which neuron is getting activated, and it is connected to with which neuron, and what set of neurons are gets activated when you are doing some task. For example, you are you're walking on a road, right? You're walking on a road, immediately there is a big vehicle coming in front of you. Immediately you can take a decision in a fraction of nanoseconds, right? So, but how much time it's going to take to reach your decision to you, means how many neurons are getting activated and how the neurons are going to be responded. It's happening in a couple of nanoseconds, right? But even it's not going to be done by a single neuron. There are set of neurons are getting activated in our mind, but we don't know exactly what is happening, but something is happening, right? So that is what block box. Even if you take some data, maybe some images or maybe some video or maybe some numbers, any data set, if you take, you can use the data for training. You can train it, but after training, what is happening? You will come up with a model, right? What is model?
A program.
What is model?
Uh, a program.
Yeah, it is, I can say, maybe finding out the best fit between
Right.
input and output, or maybe finding out the better patterns from the data,
Better
or
outcome.
maybe, yeah, maybe finding out the better relationship between your input and output, right? But exactly we don't know, while training and while giving a model to us, exactly what is happening, we don't know exactly. Okay. So it is identifying the better patterns, or it is identifying the better relationship, or it is coming up with the best match. But still, exactly how it is doing, what it is doing, we may not be very clear. Maybe if it is a very small data set, even everyone knows the logic, everyone knows. But if it is a large data set, especially if it is a image or if it is a video, then maybe you may not be familiar with what is happening. Okay. And especially when you are using a neural network means basically it is simply collection of neurons. It's not a single neuron, it's a collection of neurons. So every neuron is going to be gets activated depending on some input what it is received, and it's going to perform some action, and it's going to give us some output. That output is going to be again given to the next neuron. So it's a set of actions are going to be performed by the couple of neurons. That is what we can say neural network, right? So neural networks basically it consists of different neurons, a set of neurons, and every neuron is going to be connected with the different types of layers, right? So every neuron is going to receive the input, and it's going to perform some action, right? So the action is in terms of deep learning, we can say it is a mathematical operation it will do, and also it is going to pass the result to the next layer. Okay, why neural networks are required? In machine learning, actually, we don't have any neural network, but why in deep learning it is required?
Mostly
Any
for
answers?
mostly for images, videos, media, uh, because we have to extract the features
Okay.
and neurons. While training, it will extract the different features into the different neurons, and it get trends. And when we provide the inputs image, then it compares with the neurons and it get activated and it passes to the next layer. And likewise, we get the
Means
final.
you're talking about in terms of complexity.
Sorry.
So neural networks are required. The reason is they are very powerful uh, models, especially for complex data, or when the data sets are very high. So they will give us the better.
Mhm.
बस वक्त नहीं साले बेटा नहीं बेटा पप्पा को कम पड़ा तो इसमें थोड़ा डालो ना तुम
Piyush. Oh no, even I can't. Okay. Okay. So neural network is it's purely math actually. You can say it's a pure mathematical, right? So they will find the better relationships, better complex patterns they will find. So if we talk about the normal machine learning models, so let's say for example any classification model or any regression model, what they will do is they will sometimes if you are using some non-linear relationship, if there is some non-linear relationships in the data set when you are using any ML model, so they may struggle to find the better relationship, or they may struggle to find the better model, especially when you are working with non-linear data sets, right? So, but in that case, if you use neural network, so definitely as neural network is having, as I mentioned, there are a couple of layers. So it's going to identify the better relationships when your model is having many layers. Simple example. For example, you you will go for some two-way verification, right? Nowadays there are many social networking websites. They are asking for a two-way authentication, right? So maybe one-way authentication is fine. Let's say you have your login ID password, but still they are asking you to you can verify your mobile maybe through OTP, or they will ask you to enter your password 2 times. Why they are asking? Why not why not it is for 1 time? Why they are asking 2 time or 3 time? So 2 time means nothing but they are adding one more layer, right? For example, there is a company, they are asking to recruit some freshers, right? So if they're asking to recruit some freshers, there are only 10 openings are there, but there are thousand students are applied. So their objective is what? Select the best 10 students out of 1,000, right? Yes or no? So this task can be done in many ways, right? I want to select 10 students from 1,000 students. I can do this in many ways. Maybe if I filter their percentages, top 10 percentages, maybe the top 10 students, I'll give the job to the top 10 students. This is very simple approach. And next approach is I may filter some 100 students from 1,000 depending on some criteria. For top 100, I may plan some exam, and in that only I'll take top 10. This might be the other approach. Yes or no? Now tell me in these two, which is best? Maybe some of you are worked as a HR, or maybe they are in recruitment team. So in these two approaches, which will be the preferred one? I hope you understand my question, right?
Akbar, I didn't get what is neural network.
Yeah, that is what I'm talking about. Neural network is nothing but it's a collection of neurons. What is computer network? Do you know computer network?
Yeah, wires and all.
What is computer network?
Uh, Wires. I mean, one computer is connected with another computer. All that thing.
Same neural network also. One neuron is getting connected with other neurons. Okay, what the neuron will do?
They will do some complex.
They will do some complex operations.
may-
So
and
neural network is nothing but simply it's as I mentioned, it is derived from the biological neural networks what our human brain is having, right? You have biological neural network like our brain, what we have, right?
okay.
So what it is going to do, our brain, or we can say biological neural network, what it is going to do?
They will pass the information from one neural to another.
Yeah, in general, it is used to process the information, right?
Right.
So whatever may be, for example, as I mentioned, a couple of examples, I asked a question. So maybe you need to process my question to answer something, right? Or you want to take some decision. So then your brain is going to process the information, whatever you have, so that you will come up with some conclusion, right?
But same thing machine learning models are doing, right? I mean, you have trained that
Yeah,
data.
just we are replicating. Replication of the biological neural network into machine is what we can call it as artificial neural network. That's why I mentioned it is a black box, right? Understood?
But machine learning is also, I mean, somehow
No, not machine. In machine learning, there is no neural network, right? In machine learning, we don't have any neural network concept actually. In deep learning only, we are going to use the concept of neural network.
okay.
Okay. Anyway, I'll maybe you can understand after a couple of examples. So let me talk about very basics actually. So even neurons means like let's say it's one of the basic unit in the neural network. So every neuron is going to receive some data. That data we can say input. Okay, and that input is going to be processed by the neuron, and it is going to produces the output, right? And the output is processed to the next layer. So again, next layer, in next layer, there are a couple of neurons are there. And again, they will receive this as an input and they will process. And again, they will give the output that will be passed to the next neuron and so on. Because it is a network of neurons. That's why it is neural network. So every neuron is connected to the other neurons. So, and uh, every neural network is connected with different types of layers. Basically, we have a input layer, output layer, hidden layer, right? So now the question, actually, I asked one question. The question is, I have 1,000 students appeared for a company recruitment. They applied for a job. Only there are 10 jobs are there. How can we select the top 10? Your objective is you need to select the best 10 students out of 1,000. How can you select the best 10? I given two approaches. One approach is straight away you can take their percentage, top 10 percentage students. You can assume they are the best. Straight away you'll give the job to them. That is one option. Second option is maybe you can eliminate some people from 1,000. Let's say you eliminate 500 people or 900 people, depending on some criteria, and remaining 100 people, maybe you can have some test, and in the test, who are the top 10 students, then you can pick up these 10 are the best students. So these two approaches you may follow. Of course, apart from these two, you may follow many methods as well, but which will be the better option?
Second one.
I given two methods, two approaches, approach one and approach two, which will be the better approach?
The second one.
Even I feel
Why?
second one.
Yeah, why? What might be the reason?
So you're saying you'll eliminate a few of the people based on certain criteria. So whatever, like based on the description, job description, whatever criteria is required based on that, those candidates will be eliminated, and the certain people which we have selected. So we can apply assessment on that and then select them amongst those.
Okay. Yeah, but okay. So only you're telling that only I eliminated some people. Only because of that reason, you felt that this might be the better option, or is there any other reasons?
Filtering, because on every layer we are filtering out the no, least best outcome. So
Yeah.
in every filtering, we are getting the best outcome. So by the end of all
Okay.
filters, we'll get the top 10 students.
Okay, then it is the case, then maybe we can add some more layers in between. So instead of eliminating, let's say 900 people, maybe I eliminate only 500 people. So for remaining 500 people, first eliminate 500 people, I can say first layer. Okay. Then the remaining 500 people will goes to the second layer. In second layer, I'll conduct a written test. So maybe from the written test, I'll pick up 250 students. So now in third layer, 250 students are there. So from this through 250 students, so I'll conduct a technical interview. So from 250, maybe I'll pick up let's say some 20 students. So in the fourth layer, now only 20 are there. So from fourth layer out of 20, so maybe I'll conduct maybe GD or some HR interview. So in the fifth layer, finally I'll pick up 10, right? So now this is better than the previous one? Now I have 5 layers, right? 5 layers. In the first example, straight away I mentioned, you can pick the top 10 students by their academics. Maybe the student who is having good percentage, maybe you can pick them as a top. Straight away you will select these 10 are the best students. And second method I mentioned, you eliminate from 900, you can eliminate from remaining 100, maybe you can conduct exam, and who are the top 10 students, so they will be the best. And third approach I mentioned, we'll go with the 5 layers. In every layer there will be a criteria, or there will be an elimination, so that these people will not go to the next layer. Understood? So in these 3 approaches, which is best? Which is best, 1, 2, or 3? One, two, or 3? Which is best? Obviously 3, right?
Yes.
Of course, forget about the complexity. Okay. Here we are not at all focusing on the complexity of the maybe time or space. It doesn't matter, because always we'll in DL models, especially we'll focus on the efficiency. Always we'll focus on performance or efficiency. We don't focus on of course complexity also matters, but complexity is not high priority than the efficiency. If you compare your any programming related task, so mostly you may talk about only 2 things. One is time complexity, next one is space complexity. But here, as far as the data science models are concerned, so you don't bother about time and space, because if you want to train any data, obviously you need a high-end computational resources. Okay, so high-end computational resources, even if you compare with expensive, they're too expensive. Okay, so that's why here actually the complexity is the least bothered thing. Only we will focus on the efficiency, or we'll focus on the performance only. Okay. So now, if you observe, there are 5 layers. The example what I given just now, there are 5 layers. In every layer, what we are going to do is it's recognizing. The model is recognizing the different patterns, different uh, students. Okay, who are good uh, in that particular aspect, right? So obviously, at the end, we may come up with only the best students. Okay, understood? So it's a layer by layer approach. In neural network, basically, every layer is going to be doing some operation, and it's going to give some outcome. and this outcome will be given to next layer as input, and next layer is going to perform some operation, some processing, and it's going to give the outcome, and that will become input for the next layer, and so on. In that way, that neural network is going to work. Understood? Okay, it's very simple. We need to, for example, let me give some simple example. For example, you want to teach a kid, trying to identify some picture. Okay, you want to teach a kid, trying to identify some picture. So then, how you are going to teach a kid? So based on some features in the picture, right? Based on some features. So let's say, for example, the kid is going to start recognizing the features step by step. Let's say, for example, first maybe he may identify the ears, maybe then he may identify the color, maybe then size, maybe. Okay, so in first layer he may identify only ears. The second layer he may identify only color. Next he may identify only size. So like that, every layer is going to extract some complex features of the data, so that maybe one layer is going to learn to detect the edges in the image, and other layer is going to detect some shape in the image. Other layer is going to detect some objects, maybe like animals or some faces, right? So it is straightforward. It's not a single layer. It's not a single layer solution. So even though you might have your own logic, but the kid may have his own logic, but it is not going to be happening in a uh, in a one layered model, right? Understood? Is it clear? Of course, it is a repetitive process. So we are going to recognize different types of uh, different types of features in every layer. So in a single layer, you may identify some features. In the next layer, you may identify next features. Very simple. It's very simple, straightforward. So if you are going to appear for an interview, okay, first time you are appearing for an interview, then maybe you may fail the interview. All right. So maybe whatever the mistakes you did, you may identify, and maybe you will try to prepare the answers for the questions which are not answered. So that might be the first layer. So it does not mean that only only in the first layer, with the first layer itself you are able to get the job, right? So maybe you appeared for second company. So maybe in that company you may extracted new features. They may ask some other questions which didn't asked by the first company, right? So in that company you may extracted some other features, right? So like that you appeared for a couple of companies, and once you extracted all the features, every layer is nothing but let's say a separate company. All right. Once you extracted all the features, then definitely once if you are appearing for any company, then definitely you will be get selected. It's a layer by layer, uh, reading or understanding all the features or getting all the features, not going to happen in a single attempt, or it's not going to happen in a single layer. Understood? Just I'm trying to explain this in a layman perspective. But of course, there is a lot of math involved in every layer. Okay, identifying some features is there is a lot of math involved. Is it clear? Any doubts so far?
No.
Okay.
Hello, Akbar. Are you sharing only Notepad or any other thing also? I can see
No,
only.
no, 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 no. Actually, I'm not sharing anything.
Oh, okay, okay.
Okay, so actually, this implementation things maybe uh, we may starts from tomorrow or maybe from next week. Just I want to explain all the basics relating to deep learning before proceeding to the implementation in
Okay.
Jupyter.
I was just asking about the screen. Only Notepad is there, right? I
Yeah,
got
yeah,
my
yeah.
screen.
Only notepad only I'm sharing as of now.
Oh, okay, okay, fine.
Okay.
Yeah.
So it's uh, as it's a layered architecture. It's having a layer by layer where every layer is going to learn something, learn some pattern from the input, right? So that it is going to be identifying. If we talk about any image processing or anything, it's going to identify the images. As one layer is going to identify edges, one layer is going to identify the shape, one layer is going to get the features, so one layer is going to get the texture, right? So this is how it's going to work. So now, but in every model, so already you are familiar with the ML models, but in deep learning, uh, so far whatever we seen in ML, so all the ML models are especially during training, we may not take much time, right? Immediately within a couple of seconds, we completed the training part. But when we talk about the DL part, so definitely it's going to take more time because DL is mostly uh, involves with images and as well as videos. So it's going to take most of the time for to train any type of data, because getting features from image or getting features from video is not very similar to what we seen in machine learning. Just it's getting some data from a data set, whatever we seen in ML, right? So in general, we are going to give some image. Let's say if I talk about any image, we'll give some image to the first layer of the neuron. Then after that, this input layer is going to find some patterns. Okay, and next we will have some couple of layers. So and the other layer is going to find some other features. Let's say the image is some animal, or if the image is some human being. So first layer may identify some features. Second layer may identify some nose, eyes, and lips, etc. And then other layer. Then we'll go to the other layer. Other layer may identify some other features. So like that, it's going to identify the complex patterns from the entire data, right? So once you are given any new image, once you are given any test data, so similarly, it's going to give you the prediction, right? Like how what we did in ML also. So we are given the data for training, and once the model is ready, it's going to give you the prediction. If you give any new image, or if you given any new data, then obviously it's going to give you the uh, what it is predicting, right? Okay. So the thing is here, you need to understand what is the difference between DL and ML. That is what first you need to uh, understand. So what is neuron? So neuron is basically it's a simple one of the processing unit, like how our human brain is having nerves, right? So again, every neural network is going to have a couple of neurons, and neural networks are uh, 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 are going to be there in different layers format, right? So there is input layer, there is hidden layer, there is output layer. So there are a couple of layers in every neural network, right? So all these neurons are going to perform some operation to complete the task. The task may be classification task, the task may be object detection task, or maybe action recognition task, or any type of task. So we'll perform many types of applications through deep learning, right? I can classify a mini image. Let's say I'll classify an image to, let's say, male or female, or I'll classify an image to, let's say, cat or dog, or I'll classify the image to let's say uh, pen or pencil. So image classification is one of the important application what we'll do with deep learning. And apart from image classification, even we do object detection. Object detection is, let's say, for example, image classification means only one image is going to get only one label, right? So there are only two images are there, cats and dogs. If I give a new image, it may be classified as either a cat or a dog. That is image classification. What is object detection? So object detection is nothing but in the same picture there are a couple of images are there, and every image is going to be labeled with a particular box, right? So maybe we can say that is a bounding box. Every object is going to be recognized or surrounded by it's a bounding box, right? So there are a couple of labels associated in a single image, but the classification is concerned only if it is a binary classification. Maybe you have two class labels. If it is a multi-class classification, you have a more than two class labels, right? Understood? So of course, all this, even whether it is a binary classification, multi-classification, whether it is a image recognition or action recognition or video classification, all these are different types of applications we can use in deep learning. And again, there are many built-in models are available in deep learning. If you start with uh, there is a Google Net, there is a ResNet, there is a VGG net, right? So even there are different models for object detection. We'll have single shot detection, we'll have a convolution neural networks, we'll have a you look object once. So there are many built-in models are available in uh, in the aspect of every application. If you talk about classification, image classification, then there is a separate model. So there are many models already, proven models are there. So just what we need to do is, if you want, you can build your own model from scratch, or even you can use the model which is already available. You can customize it, right? So we'll see what this neural network is going to be used, and what it is going to do, and what math every neuron is going to perform, right? So as I mentioned, why neural network? Because every neuron in a neural network is going to perform couple of operations. What type of operations it's going to do? It's going to do let's say a product operation. So product means it's a type of multiplication. Like if you remember, there is a regression concept in ML, regression. So what regression is doing? Anybody remember what regression will do? If you remember, there is a simple linear regression model. Let's say y is equals to mx plus c, right? So this is a simple linear regression model. So here what it is doing? So x is nothing but input and y is nothing but output. So this m is, I can say, it's a weight of every input. So weight of every input is getting multiplied with the input. So here, let's say if I expand this, I can write y is equals to m naught x naught plus m1 x1 plus m2 x2 plus m3 x3 plus so on, right? So what is m1, m2, m3 and so on? They all are nothing but weights. What is weight? So what is y? Y is the outcome, right? And x is the input. So for getting this outcome y, every input is going to be involved. Every input is going to be involved with certain weight. That is what the equation is meant for, right? Yes or no?
Right.
For example, if you want, for example, you appeared for a company. So let's say the company, let's say y is nothing but the result. The result is nothing but, let's say the company is conducted some written test. So written test, they are given some weightage, let's say 20%. And they conducted some technical interview. So for technical interview, they may give, let's say, some 40%. And they conducted some HR interview. So for that, they may give some weightage of 20%. And they may see in your academics as well. So academics, they may given some 10% weightage. And even they may give a weightage for your service. So let's say for service, they are given a weightage of 0.1, right? So this is simple equation, right? So here every feature is contributing in the outcome, right? For example, you did well in written test and you did well in tech interview and you did well in HR, but you may not have good academics and you may not have good experience, then still you will be selected. Because here academics and service, the weightage is very low, right? Even you may not have much service and you may not have good academics, but if you still did well in tech interview and even in written test HR, maybe you will be selected. Because here this technical interview is having high weightage. This technical interview attribute is having high weightage, and even written test and HR is also having high weightage. So if you do these three better, even if you didn't perform well with academics and with service, then still you will be selected, right? Yes or no?
Yes. And what is C?
C is nothing but it's a random error actually. It's nothing but an intercept. In terms of regression, we can call it as intercept, but it is nothing but in general, as far as the regression is concerned, it is nothing but random error. If you remember, I given an example. For example, you are using, you went to some supermarket and you bought some sugar. Okay. The weighing machine in the supermarket is, let's say you bought five kgs sugar. The weighing machine in the supermarket shown you like it's 5 kgs, but even you have weighing machine at your home as well. So when you come back to home and you cross verified, maybe it is showing, let's say 4.97 kgs. So that is nothing but some random error. That C is nothing but random error.
Got it. Thank you.
Okay. Or maybe you can say it is a miscellaneous in terms of this particular example, you can consider as a miscellaneous. Okay. So here, this is what actually product, I'm talking about product, what every neuron is going to do. Every neuron is going to perform one of the operation. That operation is product operation. What product operation it will do? It's going to perform the product of input with weights. So here, what is input, what is weight in this example? In this example, input is written test score is input, technical interview score is input, HR input, and academics input, and service input. The weights are, this is 0.2 weight, and 0.4, 0.2, 0.1, 0.1. These all are nothing but weights, right? Yes or no? So this operation is going to be performed by the neuron. So as I mentioned, when you give any data, so when you give any data to any neural network, so what neural network is going to do? So in general, let me show you. what it's going to do is, let's say for example, it's going to perform the product weights. So let's say for example, this is one neuron, this is other neuron, and this is other neuron. So there are let's say there are 4 neurons are there in my network, and every neuron is going to have some weight, and all the weights are going to be merged together. Okay, it is having some weight, and it is having some weight. So it is having some weight, it is having some weight, it is having some weight. Okay, and it's going to apply some activation function, and finally we'll come up with some output. So this is a simple example how this neural network is going to work. Of course, it is a very simple neural network. It is not having many complicated structure. It's very simple structure. So let's say I have some input. First input I have x1. Okay, this is my first input, and I have x2. Second input x3, and even I have x4. So there are 4 inputs are there, and every input is going to have a weight, as I mentioned. The weight of so the weight of this input is, let's say, this input is having weight of W1. Okay, and this input is having weight of W2. And this input is having weight of W3. And this input is having weight of W4. So every input is going to have some weight, right? So what neuron is going to do, as I mentioned, neuron is going to do this multiplication. So here, this is going to perform x1 into W1, x1 into W1, and x2 into W2, x3 into W3, x4 into W4. So finally, it's going to perform the summation of xi into wi. So what is summation of xi into wi? What is summation of xi into wi? This is what I explained here, right? Can I say this is summation of xi into wi? This written test into 0.2 plus technical interview into 0.4. So what is input here? 4 inputs. This is written test, this is technical interview, this is HR interview, this is academics, right? 4 inputs are there, and for every input there is a weight, right? So 0.2 is weight for let's say 0.2 is weight for written test, and 0.4 is weight for technical interview, and 0.2 is weight for HR, and 0.8 weight is for service. Understood? Is it clear?
Yes.
Okay, so what neuron is doing? Neuron is doing the product of each input and the weight of the every layer. So product of input with the weight of that. Okay. So here weight means 0.2 weight for first input, and 0.2 weight for second input, and 0.2 weight for third input, and 0.1 weight for fourth input, and so on. So now once the product is done, then what we'll do is the sum of weights are going to be computed. The sum of weights. So that is what I did actually. The sum of weights are computed. The sum of weights are computed. Weight means the sum of weights. The sum of product of weights are computed. That is what I wrote sigma. Sigma means the summation of the product of the weights, right? So this is also known as weighted sum. This is also known as weighted sum. That's why I wrote sigma here. Sigma means weighted sum only. What is weighted sum? This is weighted sum of input and weights, right? And for every neuron, there is a bias. Bias is also going to be added for every weighted sum. So here, as you asked, this is nothing but bias. As I mentioned, some random error, right? So C means bias. So for every neuron, bias value will be added. Bias value will be added to the weighted sum. So now when I add this bias value to the weighted sum, what it will become? It is nothing but sigma of Wi xi plus b. So where b is nothing but bias. As I'm talking about bias, it is nothing but a bias. Okay. Sigma of Wi xi plus b. B is nothing but a bias. Okay, na? Bias means a random error. As I mentioned here, C. So here I'm talking about the bias. This is what every neuron is doing. It's doing some computation, and the result will be passed to the next neuron. Again, next neuron is also going to perform some computation, like we're multiplying weights with inputs. Okay, and it is going to apply activation. So because activation functions, now once we got the weighted sum, here, so here we need to apply some activation function. The activation function, again, it is a separate topic. I'll discuss activation functions. There are different types of activation functions are there. So for the sum of the weights and inputs with bias, we need to apply the activation function, right? So activation functions are basically, the purpose of activation functions are to introduce some non-linearity in the network. Non-linearity. Of course, there are different activation functions are there. Anyway, I'll explain. So far, is it clear?
Yes.
But why are we adding bias to the
Bias is it's a random error. That's why bias is it's a random error.
So, but why do we add it?
No, it is a part of the neuron only. Okay, for every layer, it is going to take some of the weighted sum of the inputs and as well as bias.
Okay.
Okay, so once we got the weighted sum with the bias, and it will pass to the next layer, depending on the number of hidden layers you have in the network. So once you got the final outcome, so that will be given to the activation function. So activation function is basically what it is doing in the neural network is it's going to perform the transformation. What transformation? Maybe input may be in different formats, but output I want, let's say for example, my problem is image classification problem. So I want to classify the input into either a dog or a cat. But it's not in the binary classification problem. So I am taking some inputs, I'm taking some features, but at the end, what I need to get? I need to get 1 or 0. 1 means maybe cat, 0 means maybe dog. So how can I get this? I need to do many transformations, as I mentioned, many math. So that math is going to be done by your transformation function, that is also known as activation function. Understood? So anyway, you may understand very basics now. You may not get clarity on this, why bias and what math involved, what is activation function. But as of now, you try to understand. Maybe in couple of days, maybe in 2 to 3 classes, you will get clarity on what we are talking about, as it is the first class in deep learning. So you may not be understand all the things whatever I am talking. There are many things which involves lot of math, and as well as lot of background knowledge is also required. So you may understand the things slowly. Don't worry about that. But as of now, just you understand, like it's a layered approach. Deep learning is a layered approach, and it is going to have neural network where every neuron is going to perform some mathematical operations, that is to process the input, right? To process the input, it is going to perform. Understood?
So on the weights, we applied activation functions.
Sorry.
On the weights, we apply activation functions.
After we got the weighted sum.
Okay, so yeah, I mean for the each inputs there is weight applied, right? And after that, this sigma xi wi and plus bias will get the weighted sum, and on that weighted sum we have to apply the activation function.
Yes.
Okay.
Okay. Activation function is basically, for example, I want to use binary classification problem. For binary classification problem, what is the outcome? Maybe only two outcomes are possible, right? So for that, I can use one activation function. For example, I have a multi-class classification problem. Let's say there is a problem. The problem is I want to recognize the digits. Okay. Then the problem may be I want to have, let's say there are 10 digits, right? So it is not like a cat or a dog. It is multi-class classification problem. I can recognize the digit as maybe 0 or 1 or 2 or 3, 4, 5, 6, 7, 8, 9, right? Understood? So then I'm supposed to get the probability. Here also I'm going to get some numerical value. So probability. So whether let's say, for example, I have some I will give some image. Okay. So when I given some image to the model, let's say I'll give this image to the model, right? This is a handwritten image, handwritten digit in the form of image. So when I given this is image, of course, it's in the form of pixels, right? Image means basically it's a grid of pixels, right? Yes or no? It's a grid of pixels, yes or no?
Yes.
Okay. So now what we need to do, we need to classify, okay, that image into one of the class. The classes are, there are 10 classes. Maybe class 0, class 1, class 2, and so on, class 9, 0 to 9. So total there are 10 digits, right? Means 10 classes. So then how it is going to give me the output? It belongs to class 1 or class 2 or class 3, something like that. How it is going to give? So again, there is a probability, right? So there will be a probability. Understood? Is it clear?
Yes.
Okay, na? So there we are going to, means depending on the type of the problem, we are going to use different types of activation functions. So if it is a binary classification problem, we can use a different activation function. If it is a multi-class classification problem, we are going to use separate activation function. If you remember, we discussed about logistic regression in machine learning, in classification algorithm, right? So then there we used one activation function, if you remember, sigmoid. Okay, sigmoid is also one type of activation function. So why we used sigmoid actually? What is the use of activation function there? Because we need to classify the data into two classes. Okay, it's a binary classification problem, two classes. So if I want to classify, I need a threshold. I need a threshold. So if it is more than 0.5, I can say it is belongs to class 1. If it is less than 0.5, I can say it is belongs to class 0, right? So, but my input may not be in the range of 0 to 1. My input may be in the range of any values. My input may not be in the range of 0 to 1, right? So to convert the input in the range of 0 to 1, we used activation function there. In general, the data may be in the range of minus infinity to plus infinity, because we never knows what values are there for every attribute. Understood?
Got it.
Okay, so basically what we'll do is we are going to use some activation function. So that activation function is going to introduce the non-linearity. As I mentioned, it's going to introduce non-linearity in the network, so that it's going only, maybe there is a question. The question is, why activation functions? Activation functions are going to be used to find the complex patterns. That is non-linearity. As I mentioned, one of the problem in machine learning is, what is the problem? If the data is having non-linear relationship or non-linear patterns, then your ML may not recognize the non-linear relationships in a better way. So that is the reason why here we are introducing neural network. In neural network, there are many layers. Every layer is going to be responsible to identify the complex patterns. And also uh, there are activation functions. So the activation functions will introduce the non-linearity. So the main objective of the introducing activation function is to identify the complex patterns. Understood? Is it clear? Yes or no?
Yes, sir.
Okay. So yeah. As I mentioned, there are a couple of things you must be aware of. Okay, but all the things as I mentioned, you may not get it as of now. Once we go into the practice, once we are going on with the hands-on, then you can understand the things what we are talking about. But yeah, anyway, the thing is, you need to use activation functions, and also we need to use the couple of, even the number of layers. As I mentioned, obviously the number of layers, more number of layers will identify the better features, and also will give you the better results. That's what I said. One example, the company campus example, right? The first example, when you want to recruit some 10 people, so maybe you can add a couple of layers. So that is a reason where if when you work with real-time data sets, the data sets may not be in different format, or may have different types of relationships, may have many complex patterns. So hence we need to use many layers. Okay. So let me explain what we'll do in deep learning life cycle I'll explain. Okay. Because we are going to follow almost the same life cycle for many projects, what we are going to do in deep learning. Let me explain the deep learning life cycle so that first some steps are common in ML and DL. Okay. So first step is, as usual, we need to uh, identify the problem. Problem identification is very important because you must know we can solve many problems using deep learning, but the problem identification is problem definition is very important. You need to identify what problem you are going to solve, right? So you can do many applications, maybe image classification, or whether it is a regression problem, whether it is a uh, action recognition problem, whether it is a object detection problem. So there are many models for every problem. Okay. So let's say, for example, you want to identify, or you want to classify the image, whether image is a male image or female image. So that might be the one of the problem identification. Or you want to detect a person image uh, in a photograph. Want to detect a person image in a photograph. Let's say, for example, whenever there is any crime is happened, so if they are unable to identify the person, what they will do? They will release the sample image, right? They will release the sample image. Maybe this person is having a so and so features. Maybe he's wearing this so and so shirt. So okay, so they will image the sample image of the a particular person who did the crime, right? So how they will do? How they will release that image? That is through deep learning only, right? Understood? I hope you understood problem identification, right? So you need to identify whether you are going to work with the problem identification, means whether it is a image classification problem, or whether it is a object detection problem, or whether it is a action recognition problem. Action recognition problem, or whether it is a um, regression problem. Okay, all this depending on the problem statement, you need to identify what type of model you need to build, right? Example, as I mentioned, example, let's say the problem is the image classification. So if you are going to talk about image classification, we need to identify, or we need to classify the given image as uh, horse, or okay, as donkey. Okay, this is the problem. Given an image, we need to identify, or we need to classify the image, whether it is a horse or a donkey. So what type of problem it is? What type of problem it is? What solution you need to find now? What is this problem? We need to classify the image as horse or donkey. What type of problem it is?
Classification, binary
Class-
classification.
Yeah, it is a classification. For example, let's say, let's say we need to detect the tumor, in CT scan. What type of problem it is? What type of problem it is? detecting the tumor in CT scan or detecting the tumor in X-ray. Okay, what type of problem it is, or detecting some abnormality in the CT scan. What type of problem it is?
Image,
Object detection, right?
right? Object detection.
Yeah, because not only tumor, there are many objects are there in the CT scan. And there are many things involved in that picture, but we need to detect only whether there is a tumor in the picture or not. This is object detection, right? Sir, no. So
Right.
first you need to know what type of problem you are going to solve. What type of problem you are going to uh, use the deep learning to solve which type of problem. That's why problem identification is very important. Once you identify the problem, then now tell me, for example, if this is the problem, what we need to do? What is the solution? This is the image classification problem. What is the solution? We need to build a model, right? We need to build a classification model in such a way that if I given some test image, if I given some new image, then my model is going to classify whether the image is dog or cat or horse or donkey, right? Yes or no? That is a problem statement, right? So build a deep learning model to classify the given image horse or donkey. That is the solution we need to find. Yes or no? Or if it is object detection problem, then we need to build a deep learning model to detect the tumor in the CT scan. This is what we need to build, right? Understood? Is it clear? The problem identification.
Yes.
Okay. Next step is once you identified the problem, next we need to collect the data. Okay, so data collection. So data collection as usual, even it is there in even ML also. So we need to get the data sets from different sources. So we need to gather the data, whatever the data required, you need to gather it from different sources. So data we may get it from different sources, maybe from sensors, or maybe from some website, or maybe from some files, or maybe from database. Okay. So data collection is nothing but gather data from various source. Gather data from various sources. So the sources may be anything. For example, let's say you want to detect tumor in CT scan. Maybe you may collect data from even hospital as well, right? So maybe the sources may be maybe some websites or websites, okay, or even other sources like maybe some sensors, or maybe some sensors, or maybe from some files, or maybe from some R&D organizations, okay, etc. So these are the different sources, because the data may not be available and it may not be enough if you collect it from single source, right? For example, you want to do this tumor detection problem. So if you want to do tumor detection problem, the data may not be sufficient from one hospital. You may get it from different hospitals. Even you may get it from different R&D organizations. Okay. So that you will get it, the data, whatever required, right? Understood? So for example, what is the data set required for this? This is the problem. So then, for example, what data collection required for our example? We need a data set of we need a data set consists of labeled images of horse and donkey, right? So for this use case, just I'm talking about only this particular example, right? Yes or no? Because first you must know what is donkey, what is horse, right? Yes or no? Even if you want to detect a tumor, first you must know what I mean by tumor. You may not blindly say this is a tumor, right? Is it clear so far? Please do respond yes or no.
Can you repeat, Akbar? What did you say?
For example, if this is the use case I'm talking about, okay, the use case is image classification. Let's say the use case I'm talking about is I need to classify the image whether it is a horse or donkey, right? So for the problem, we need to build a classification model. So we need to build a model so that the model is going to effectively classify what is horse, what is donkey, right? Yes or no?
Yes.
For that, what we need to do is we need to build the model, right? So to build the model, what I need data set, right?
Yeah.
Because I must know what is dog, what is cat, or what is horse, what is donkey, right?
We'll feed the model with different images of donkey and dogs.
Yeah, yes. Because if I don't have any label, I don't know what is horse, what is donkey, right? Maybe you may know because human beings may know, but how machine is going to understand which is donkey, which is horse. We need to train the machine, right, with different features. If you see this feature, let's say this is a horse. If you see that feature, then you can say it is a donkey, right?
Yeah.
Okay. So if you want to build a model, definitely you need a data, right? Large data set we need because there are some similar features are there both in horse and donkey, right? Yes or no? Yes or no?
Yes. Yes.
Yeah, that is the reason why we need a very large data set so that we'll come up with a better model. If you don't have any if you don't have large data set, if you don't have labeled data, then definitely you may not get the better model, right? I hope you understand what do you mean by labeled data, right? Labeled images.
Yes.
Okay, labeled means for every image there will be a suitable title. So whether it is a horse or whether it is a donkey. Okay, if it is only image is there, it is unlabeled. Already in ML, we discussed what is uh, unsupervised learning, what is supervised learning. At the time I mentioned what is labeled data, what is unlabeled data. If you remember.
Yes.
I hope you understand what is image labeled images, right? Is it clear? Step number 2.
Yes.
Okay, next we'll go for as usual. Even in ML also we need to go for data pre-processing. Even in deep learning also, we need to do lots of data pre-processing. So data pre-processing. So what do you mean by this data pre-processing? And what type of data pre-processing we'll do? So data pre-processing, the main objective is we need to prepare the data for the deep learning model. Okay, so that it is in the required format. So now I mentioned the input is what actually input image, right? We have images. We have a couple of images of let's say some horse images are there, some donkey images are there. But what input is required for any deep learning model or for any machine learning model? We need only the input in the form of numbers, right? Yes or no? So none of the deep learning models, none of the machine learning models, okay, they won't understand image format data. And also any other format they won't understand. Only they will understand numbers only, numerical format only. So I am supposed to use some method. I am supposed to use some pre-processing method in such a way that the image format data is going to be converted into numerical format. Yes, sir.
Yeah.
So for that, we need to do the pre-processing. So in this pre-processing, we need to do couple of operations. So pre-processing is nothing but, as I mentioned, preparing the data for the model. Preparing the data for the model. So by performing different operations, by doing maybe we can do cleaning. So that is known as data cleaning, or even we can go for data transformation. And go for data cleaning, data transformation, and also we need to go for augmentation sometimes. If required, we'll go for data augmentation. And even we'll go for encoding as well. So these are the different pre-processing techniques we need to perform to convert the data into the required format. Okay, so for example, what do you mean by cleaning? So cleaning is nothing but, because data pre-processing is one of the crucial steps to get the better model. Okay, we can say it's one of the important step. Important step to get the better model performance. Okay. Here what we are doing, we may go for cleaning. So cleaning means, let's say for example, I may remove the unnecessary data. Cleaning is nothing but removing unnecessary data. Or maybe duplicate data, removing duplicate data, and also remove noise. Removing noise. Okay, this is what we can say, the cleaning, data cleaning, right? So I can remove unnecessary data, I can remove the missing data, or I can remove irrelevant data, or maybe I can remove the duplicate data. Understood? Or I can apply some filters in images. Okay, I can apply some filters, and I can apply some median filter, or I can apply some other image transformation techniques to pre-process. What is augmentation? Or augmentation is basically For example, you may do some types of transformation. If the data is not enough, maybe we'll do different types of transformation. You may go for rotation, you may go for flipping, you may go for scaling, okay, or you may go for zooming the images. What is normalization? Normalizing is nothing but you need to convert all the features to the standard range. Okay. So anyway, we'll see all these things in detail. You don't bother about all the steps. We'll do all these things in hands-on while we started the simple projects. We'll do all this in hands-on. Okay. Any doubts so far? Already you know what is encoding? What is encoding? Encoding is nothing but converting the non-numerical data into numerical format, right? Encoding is why we need to convert to numerical format? Why we need to convert to numerical format? Hello?
Because computer knows the numerical to deal with it.
Yes, exactly. Any ML model, any deep learning model, any type of model, they works only with the numbers. It doesn't know any other format of the data. It should be only numerical format. It works with only numbers. So that is the reason why we need to use only the numerical data. So that's why in pre-processing, let's say for example, if I, as I mentioned, I have some images are there. Okay, so in images, we may not see straight away the numbers, right? So then in data pre-processing, what I'll do is I'll resize the image based on the pixels. I'll resize the image to some constant size, and I'll convert that image into arrays. So image means what? Image, I can say it's an array of pixels, right? It's an array of pixels, right? Yes or no? If I'm talking about a numerical format, an image is basically what? So an image is an array of pixels, right? Array of pixels. And you know what are the range of the pixels? 0 to 255, right? So now you got number, right? You got some number. So it is image is nothing but only having numbers in the range of 0 to 255. So what is normalization here? Normalization means why I need to go with all these 0 to 255. I'll normalize this number by dividing every number with 255. If I divide every pixel with 255, what will happen? I may get maximum 1 and minimum 0, right? Yes or no? Did you understand what I'm talking?
Yes.
Okay. Image is it's a pictorial format. It can't be understood by the machine. But our model needs only numerical format. So what we'll do is we'll try to convert that image into numerical format. So you know, image is nothing but an array of pixels. So pixels again we have only in the range of 255, 0 to 255. So what we'll do, we'll try to convert that array into the standardized format. So by dividing with 255, every pixel in the range of 0 to 1 only. So now it is converted into numerical format, right? So normalizing the pixels in between 0 and 1. That's why I am dividing with 255. Is it clear? Any doubts so far?
So why do we normalize this? Amna?
normalization, because the data is in the range of 0 to 255, right?
Yeah.
Pixels. 0 means, let's say, 0 means white, or 255 means block.
Yeah, I
Okay.
understand the thing.
Yeah.
But why is it used?
Normalization is to convert the data into standard range.
Okay, so further it is used for comparison, or I mean,
No, not for comparison. So normalization is what we'll do is, I want to get the data in between in a specific range 0 to 1. So in general, if you see any of the models, okay, so they will go for standardization or normalization. What it is going to do is, instead of going for different values in different ranges, they will reduce the range to 0, in between 0 and 1.
okay.
So in general, the purpose is to avoid the numerical instability. That is one of the reason why we'll go for normalization and scaling.
Yeah.
Okay, so that all the numerical features is in the range of 0 to 1. Okay. And already encoding is basically converting the non-numerical or categorical values into numerical values, right?
Yeah.
So maybe you can use different types of encoding methods, like you may use a label encoding. The process of converting categorical values, to numerical. So how can we do this? We can do by using different encoding methods. Maybe we can use label encoding, or maybe we'll go with the one-hot encoding. Okay. Next, once the pre-processing is done, now next step is model selection. So here the model selection, depending on the type of the task, depending on the type of the problem definition, we need to choose the particular architecture, or we need to choose the particular model. So that is going to be used for your problem. Let's say, for example, as I mentioned, in this particular use case, as I mentioned, the problem is we need to classify the given image whether it is a horse or a donkey, right? So if the problem is horse or donkey, then maybe I can use a CNN model. So model selection means, what is image classification? Maybe we may go with CNN. CNN means convolutional neural network. Okay, or maybe if the problem is, let's say there is some sequential data, there is some text data. Maybe I may use some RNN, means recurrent neural network, or maybe I may use for fully connected neural network. If the data is some normal generalized problem, I can use fully connected neural network. Okay. If you want to generate some data, maybe you can use some generative adversarial network, GANs. Okay. So even depending on the type of the problem, there are many pre-trained models are available. So if you're talking about classification problem, so for image classification, as I mentioned, there are many pre-trained models are there. So let's say VGG16, ResNet, InceptionNet, okay, and EfficientNet. There are many pre-trained models are available. But in this use case, as I mentioned, I'm going to use the problem of classifying images into horse or donkey. Then I will go with the CNN for our problem, for this particular use case. So we may use CNN as our problem. use cases, and our use case is image classification. Understood? So depending on the type of the problem, you need to go with the different models. Is it clear so far? This model selection. Next, what we'll do after model selection? We need to build the model. Build the model, right? So for building the model, what we need to do? So if you remember in machine learning, what we used is we use a fit method. Straight away we have a train part, test part in both dependent and independent. So straight away we are given that independent training part and dependent training part to the fit method, so that the training part will be done. But as far as the model building is concerned in deep learning, so you need to build your architecture of your deep learning model. You need to build your deep learning model architecture. So what is, this is very important here. What is building model? Building model is nothing but you need to define, you need to build your you need to construct the model architecture. You need to construct the model architecture of your DL model. You need to construct the model architecture of DL model. What? Okay, so means what is the meaning of constructing or architecture of DL model? So there you need to decide how many number of layers you want, and also you need to define the neurons. You need to define activation function. You need to define the loss function. You need to define optimizer. All this you need to define. So that is what model architecture. So model architecture consists of define layers. Define. You need to define layers, and also you need to define neurons, and also you need to define the activation function, and you need to define the loss function, and also optimizer. Loss function and optimizer. You need to be familiar with all this if you want to create your own model, or if you want to build your model. Understood? So here there is a lot of difference between ML and DL. In ML, what we did here in this step, what we did as far as the machine learning is concerned, what we did, we did all these steps. In machine learning, did we do all these steps?
Yes, but not that build the entire model.
We
here
didn't created anything, right? We didn't created anything in ML, right?
yes, just train and test.
Just we splitted the data into train and test, and the training part labels and training part independent data will be given to the fit method, right? That's it. Yes or no?
Yeah, model or fit, yes.
But here what we are doing, we are giving our own parameters. Okay, own parameters means we are supposed to define how many number of layers we want, and in every layer how many number of neurons we want, and every Activation function we need to define. Everything we need to define. Understood? So is it clear so far? Any doubts? Once model building is done, then we need to go for a training purpose. Then we need to go for training. Model building is done, then we need to go for model training. Now we need to train the model. Model training. The model training is basically we need to train the model. So we need to give the data to the network. We need to feed the data to the network, and we need to adjust the model's weights and try to reduce the function loss. Okay, so in training process there are different optimizers we can use. Okay, the popular optimizers we can use Adam optimizer, we can use stochastic gradient optimizer. So anyway, we'll see this optimizes everything. Okay, so a model training involves what? Model training involves we need to feed the pre-processed data into the network. So adjusting models weights and also will minimize the loss function. So during model training, you need to also must know what is the size of the batch. Batch size. Batch size means how many samples you need to give it to the processing purpose, and also what type of optimizers you may use. As I mentioned, there are two famous optimizers we'll use. One is Adam optimizer, next one is stochastic gradient optimizer. Once model training is done, we'll go for model evaluation. The model evaluation is once your model is trained, you can evaluate the model performance on the test data. Model evaluation already you people are aware in machine learning also we did many types of evaluation. We used to have accuracy, right? So model evaluation is done on test data. After this, we'll go for parameter tuning, hyperparameter tuning. What is hyperparameter tuning? Hyperparameter tuning is nothing but optimizing the model performance. Okay, so we'll try to adjust the learning rate, try to change the number of layers, and try to change the number of neurons per layer. Okay, and it's a trial and error process, but we'll try to adjust all these parameters to get the better results. Or sometimes we may use some other methods, like we may use cross validation, or we may use grid search method to get the better model performance. Once this is done, then we'll go for model deployment. The model deployment is basically once your model is evaluated, okay, then we need to deploy the model for the production, right? So where it is going to start the predictions on real-time data sets. Okay, and once this is done, then we'll go for monitor the model. After model deployment is done, we'll go for monitor and maintain the model. Monitor the model. Maintenance. Okay, we'll go for monitor means once your model is deployed, you need to continuously monitor the performance of the model in a production environment. And also you need to go for retraining when it is required. Okay. So this is the life cycle of any deep learning project in real-time scenario. Clear? Any doubts? Any doubts? Let me know if you have any queries. Of course, we'll see all these steps in detail in the hands-on sessions. As of now, because it's the first session in deep learning. Okay, so you may understand some terms, you may not understand some steps. Okay, but all these things we'll do hands-on in maybe in the coming days, maybe tomorrow or maybe next week, next Saturday. And we'll do some more projects in deep learning, because deep learning is not a simple if you compare with ML. It's a bit complicated because it is involving images or a video, all this. The data may not be straightforward. So we need to do lots of data pre-processing as well. Any queries as of now?
Yeah, how many classes going to be there for deep learning?
Sorry,
How many classes going to be there for deep learning?
deep learning, 30 max.
30 classes.
Yeah,
You mean to say 30 weekends, right?
sorry,
30 weekends.
30 hours.
Oh, 30 hours.
Hmm. Because I'm not going in a fast track, right?
Got it. Okay.
So if I go in fast track, even we'll complete this in uh, 10 to 12 hours. But that is not the right way, because you may not get the time for you people. Most of the people are working. You may not get the time to practice the things. At least if you understand, if you attend the classes, maybe if you get some free time, maybe you may refer once. I think you may not get time to practice all the things again from scratch, right? Yes or no? So that is the reason why maybe doing some practice from your side. So I'm doing almost uh, many examples and many use cases with the different projects, so that you can understand the things. And if there is any free time, you may practice. But at least if you attend, you will remember the concepts and you can understand the projects what we can do. Understood? Okay, so I'll stop here then. Thank you.